to comment on food. Right, okay.
Yeah, then.
Let's go. Hello, I'm Tim.
I'm James.
And you're listening to QuasiCast. So, today we're discussing a legitimate paper, a paper that was published in the journal Nature, no less, probably one of the most prestigious scientific journals in the world. It's been all over the news over the last week, and it has quite a striking title, which I will quickly read out. So the title is Global Human-Made Mass Exceeds All Living Biomass, painting a picture perhaps of a rather cyberpunk 2077 future, perhaps, or maybe even a Blade Runner future. Towering skyscrapers, endless Las Vegas deserts.
Yes, I think that's the image that they're trying to conjure up, certainly. Although, yes, let's not jump to conclusions about their intentions yet. But
no, of course.
Yeah, essentially, if I may summarize, they have used existing data about the amount of mass that humans have modified in some way, whether that be extracting oil from the ground in a mechanism which we understand to be problematic, or perhaps more benignly quarrying rocks from the ground and making gravel, or mining clay and making bricks. All of that is included in the metric which they call anthropogenic mass, and they compare it to the total what's called biomass, which is in their definition is all living things, excluding marine animals and excluding humans, minus the water which might be contained within those bodies. And they make the assertion that if you track these two quantities over time, that they intersect around 2020, plus or minus 6 years.
Mm-hmm.
And that's broadly the conclusion of the paper, or certainly the findings of the paper anyway.
Mm-hmm. So, yeah, indeed, the paper concludes that we are at a crossover point, they put it, where, well, it's difficult to pin down, to be honest, exactly what the conclusions of the paper are, and we'll probably get into that later, but certainly the feeling, the interpretation that's been expressed in the many, many articles that have covered this is that Earth is at a tipping point, a point where anthropogenic mass, the impact of human activity, is overtaking biological life on Earth, and that this marks a change in the character of the planet. They make a parallel between the transition from the Holocene epoch, the most recent epoch, geological epoch of Earth, into the Anthropocene, which is a term they didn't coin, but it's a term that has gained traction recently. The idea that we are currently in a geological epoch which is defined by human activity. And that if at some theoretical point in the future, geologists were to look back over the geological record, they would find some kind of discontinuity corresponding to this era, this specific point in time, similar to that which is found in rocky strata at the Permian Triassic extinction, for example. Major changes in the biological makeup of Earth.
Yes, and I don't think necessarily there's a huge amount of controversy around that definition of that term.
No.
There are many physical metrics which you can clearly delineate a before and after, after which humans are making a clear mark. I mean, the classic example is radiocarbon dating. Which is, prior to 1953 or whatever it was. I can't remember exactly when. Certainly the 1950s. Was it the first test? First open-air test?
I think it was the first nuclear test, the Trinity test. Yeah.
Well, the first one was Little Boy.
I thought it was Trinity was the very first live test.
The one during World War II?
Well, the first detonation, I think, was Little Boy. But the very first test of an actual bomb, I think, was the Trinity test.
Okay, maybe it's from then. I always thought it was in the 50s for some reason. But yes, prior to that, you can radiocarbon date things, whereas after that, the noise in the measurement, due to the presence of radioactive trace elements, effectively from these tests, it means that you can't date anything after that date or
it
after
gets
that
very
period.
confused, and of course that has a generational impact as well, because every generation born after the Trinity test has a higher rate of unstable strontium isotopes in our bones, which means that we are fundamentally different in our chemical makeup to every human generation that's gone before. Which I
Like an
think is
X-Man.
Indeed, yes. Yeah. If only it gave us superpowers rather than just cancer.
Right, sorry, slight,
yeah, a bit of a deviation,
slight tangent there.
But what I'm curious about, James, is well, as a starting point, anyway. We can get into the details of the science in a little bit, but what I'm really curious about is people's reactions to this paper. It's a very striking title, and it certainly seems to have grabbed people's imagination. So far, yes. I think I've read 5 different articles discussing this across different British newspapers, and I've seen numerous news alerts cropping up in my feed over the past couple of days. But obviously, we're slightly more cynical, I suppose, about some of these things than perhaps many people would be, but simply because we've been trained to be cynical about academic papers.
I feel like whilst after that statement, I should just clarify for the listener that both Tim and I are well aware of the serious nature of climate change, the man-made impact on the Earth, and that when he says we are cynical about such things, what he means is we are cynical about the way in which the science was conducted, and the reasoning behind the choice of the direction of the paper and the assertions that they made, rather than the broad assertion that humans are having a too great of an impact on the planet.
No, certainly. I mean, if anyone is listening to this and they're hoping that we're going to somehow debunk climate change, I'm afraid you're in the wrong place. Both James and I are, along with the rest of the scientific world, are completely agreed that anthropogenic climate change is real and is a crisis. But that doesn't mean that every scientific paper written in that area of inquiry is necessarily valid. And it's important to scrutinize science with a neutral outlook and determine its efficacy as independently as possible. And that is what scientists are trained to do.
Yes, and I do also feel like, well, we'll touch on this in the second half of the podcast, but it's papers that get a profile such as this, i.e. very high, are saddled or shouldered with a greater responsibility to make sure that not only the science they're doing is correct, and as we'll find that the work they have done is not technically incorrect, the choice of work that they do and that they promote is important, because they could use the platform that they have, which inevitably they have got it in this case, to make more meaningful discoveries about the nature of the human impact on Earth.
Indeed, yeah. And I'm curious about the emotional impact of this paper. I don't know what your initial reaction on reading this headline was, James. I don't know if you sort of immediately started sort of finding the errors, or if it hit you with perhaps the sledgehammer that it seems to have hit a lot of people.
Well, I mean, it seems like every other day there's an article about how we're reaching a tipping point, whether it's climate change. Well, it's mainly climate change, and that, we're past the point of no return. We're just before the point of no return. Independent of the veracity of the claims, it's intense, an emotional experience to read such a thing. And in a similar way, that's kind of how I felt when I first read the title of this paper, because it's bold. It says that we have, it's the all living biomass. That those 3 words are, have a totality to them, which is disturbing.
It is. It's certainly frightening, and in your mind, it certainly conjures up a terrifying image, one where, sort of a vast ecumenopolis swamps, Earth's forests and leaves nothing but concrete in its wake. That is certainly the image that was conjured up in my mind when I read that, and being someone who's very concerned about climate change, it hit me with panic, to be honest, reading this. And it's interesting, we talk about, like you said, we talk about tipping points a lot in climate science, and I don't want to get into a deep discussion about climate science because this isn't the time. Well, it is the time, but neither of us are in we haven't spent the last week reading about climate science, so we'd be uninformed at best. But it is interesting that the idea of tipping points is a example of how scientific communication changes the way that people think. At the moment, it's quite normal and quite common for people to talk about tipping points in Earth's climate. But that idea is the product of a paper like this, a high-profile paper which gained traction in news, namely the paper Deep Adaptation, which first popularized the notion of extreme tipping points. So yes. I guess what you're saying is that while, of course, we want to treat, with the appropriate severity, research into climate change or the impact of human activity on the planet, it's vitally important that we scrutinize this work, because our emotional reactions to work like this tend to be very strong and can often overwhelm our, more rational instincts.
Yes.
Is that fair?
I think that is fair. I think... I confess, though, quickly, after having read the title and then began reading the abstract and the rest of the paper, it became apparent that there were some odd choices, shall we say, of quantities that they were comparing. Mm-hmm. I can't quite understand why they decided to compare the two quantities that they did. I think now, we can begin to pick apart what's problematic with this paper.
Well, let's start maybe with a bit of a dissection of what the paper actually says, because as is rather inevitable with something that achieves this level of traction. I mean, this paper was published on the 9th of December, and I'm looking right now at at its page on the Nature website, and on altmetric currently, which is a indicator of how many times it's been reported in the global press, it's currently reached 4,046 in 4 days.
Wow.
So to put that in some perspective, something like the paper discovering graphene achieved that kind of score in altmetric over several months. And this has achieved it in 4 days.
Yes, I mean...
Now, it's not to say that in the long term it will have a bigger impact than the graphene paper, and the graphene, Novus Lovengeim's work on graphene is another controversy that I'm sure one day we will discuss. But that is just to frame how widely reported this has been. Yes,
it is definitely a flashpoint generally in media, stories like this.
But most of those articles have focused on the implications of the title and have had very strong visceral reactions to it, and haven't gone so much into dissecting the actual content. So perhaps the first thing to do is just to break down what the paper's definition of anthropogenic mass actually is.
Yeah. Would you like to go ahead and
Sure, yeah. So the anthropogenic mass, it's framed as basically the human-made or artificial mass. So covering anything which is any mass on the planet which is the result of human activity. And the key figures here, if unfortunately, Nature has decided to put most of its articles behind a paywall, which a lot of people have been arguing against, but currently we can't do anything about it. But you can access this figure, I think, for free on the Nature website, the first figure. So figure 1 here shows the comparison between the anthropogenic mass and the biomass. And usefully, the anthropogenic mass is broken down into different sectors. So we have things like plastics and metals and bricks, construction materials essentially that have been used to create buildings or create products that we consume. But it's very noticeable when you look at this graph that by far, the two biggest contributors, over 80% in fact, of the total anthropogenic mass currently, is made up by aggregates. Now, there's not too much detail given as to what aggregates comprise, but one of the examples given is gravel.
Yes.
So I think we're assuming that these are basic construction materials that are minimally processed. The other, by far the largest contribution to anthropogenic mass, is coming from concrete.
Yes.
So when you look at this and you see bricks, aggregates, concrete and asphalt are the vast majority of this anthropogenic mass, it's clear that what we're really measuring here are buildings and the global road network.
Yes.
That's the primary thing that we're measuring.
And it should be pointed out that, it's when you're trying to estimate things, you need something to go on. And things like an estimate of the surface area of roads on the planet it's a classic estimation problem, right? And similarly, the amount of concrete which is currently, entombed in buildings, is something which you can estimate. However, more esoteric things, such as, say, for example, tilled earth in farmland, or the fencing that borders said farmland, are far more difficult to estimate.
Yeah, and indeed that touches on two really important points. One is how we tackle waste in this metric, because according to the way that this has been calculated, building waste, so materials that have been used to build something and that building has since been abandoned or demolished, is not really counted in this metric. There is a second figure which attempts to estimate the anthropogenic waste mass, but that is primarily tackling things that can easily be measured as having been thrown away. So things like discarded plastics, for example, discarded consumer goods. It's not so much dealing with construction materials, which are primarily captured by this anthropogenic mass. So in this basis, if I build something and that's later abandoned or demolished, according to this metric, that processed mass stays in the anthropogenic mass. So even if I build a house out of bricks and then I smash that house to pieces until it's nothing but dust, that mass that I've processed into bricks, that clay, which, I haven't done anything to change that. I haven't chemically processed it. All I've done is press it and fire it into a brick. But if I smash that brick up, it remains in that anthropogenic mass.
Yes.
And this is a huge problem because while it is absolutely clear that the human impact on the planet and human land use has increased exponentially, we can't, in this metric, deconvolute the simple act of compounding our consumption. So if I process one brick every year and I simply calculate the total number of bricks that I've made year upon year upon year, I will get a steady increase, a linear increase in the number of bricks that I have, even if every time I make one brick, I'm putting one back into circulation.
That's right. Essentially, it doesn't take into account recycling.
Exactly. Exactly. Which is a huge problem. But you touched on another really important problem there, because what I'm saying there is essentially that I think that it's overemphasizing the impact of construction materials, but also it's underestimating the actual impact of certain activities that we know are hugely damaging, like farming. Because
I think
you made that point there. Sorry, you go. Yeah.
I was just going to say that, that's the point I was trying to make, is that there are far more important things. It's not so much a problem of the things that they are including that shouldn't be included, as much as it is the things that they're not including which should be included.
Indeed. I mean, take something like topsoil erosion, which we know is a huge, huge problem, especially in the US at the moment. And the soil that's tilled and is then eroded, that is a critical resource that's being lost through human activity, because it's fertile soil that is essentially being destroyed. But that isn't counted here, because the tilled earth isn't being counted under processed mass.
That's right. And I would argue that in terms of the destruction of the biosphere and the de-diversification of animal life on this planet, the farming and the conversion of natural habitats into farmland is one of the primary drivers.
Indeed.
And therefore, excluding it from your metric by which you are trying to show that human impact is reaching a stage at which it is untenable is faulty at best.
Indeed. And to bring it to mention again also this overemphasizing of construction materials, that really is almost an irrelevant, I'm not totally irrelevant, but it's almost a totally irrelevant metric, because ultimately if you take resources like stone, like sand, aggregates like gravel, and you process them into construction materials, what's impacting the natural world is not the fact that you've taken those resources and you've structured them into a building. It's the mining practices, the quarrying. That's what creates the impact. If you were to create a perfect, single shaft mine where the surface impact is almost nil, and you mine out vast amounts of stone using low impact methods that don't destabilize the ecosystem around the mine, and you extract billions of tons of rock and build a big tower, the impact you've actually had on the biosphere is minimal. Yes, you've created loads of anthropogenic mass, but the materials that you're using, it's not like you're depriving the biosphere of those materials because they weren't being used anyway.
That's right.
The impact is from the practices, not the mass.
Yeah, so although I feel like what they attempted to do here was a rather misguided attempt at alluding that, the practices, essentially they're saying that we need to be creating less anthropogenic mass, and by doing so we will reduce the impact of the practices by which that mass is extracted. But, it's not a linear relationship in any way between the impact of these practices and the amount of mass which is coming out, and therefore drawing conclusions about the impact of such things from such a metric is not really possible.
Indeed, and I think that touches on one of my big problems with this paper specifically, but with a lot of discussion about climate change in general, is that the assumption tends to be if we just reduced consumption, we can solve the problem. And I don't actually think that's true. Because, yes, we could reduce the proportion of our consumption back to the level that we were at in 1950. But if we're still using terrible practices to maintain that level of consumption, it's still really damaging. And in fact, using sustainable methods, we could maintain a much higher level of consumption, potentially even maintaining our current standard of living, or better, in fact.
Yes.
Without having a major impact on the biosphere. And every paper, every discussion that comes out that basically makes this point of, well, there's just too many people and they eat too much, so there's just no way. There's no way of going forward apart from to make everybody poor and miserable and we'll all just eat turnips for the rest of our lives. Every time someone writes something that alludes to that idea, I'm not saying they say that specifically here, but it's,
yes, I think,
in my opinion, it alludes to a similar a similar philosophy, it makes people less likely to get behind green action.
Yeah, I think that's fair.
Ultimately, the
Perhaps,
message I think that we need to be putting out to people, and the message which I also believe, I believe it, but I also have studied it, is that through reforming the global economy to be sustainable, we can not only maintain our current standard of living, we can actually improve it. Sorry, bit of a diatribe there. What were you going to say, James?
I was just going to say perhaps we should talk about the other side of this metric, which is the biomass.
Yeah, absolutely.
So here, I feel is one of the really quite strange choices that they made in this paper, which is that they define the biomass to be they use the data from another paper to get their quantity of biomass, and in the original paper where this number or this value was derived. They excluded marine animals from the metric of the biomass. Now, the mass of marine animals as a proportion of the total mass of life on Earth, I mean, I'm not going to try and come up with an exact number, but it is significant, shall we say. And therefore, excluding it means that you're not really comparing it to the total mass of animals, excluding humans on Earth. It's to call it the biomass and trying to allude that it is the mass of all animals, which they seem to, is misleading at best.
Yeah, it's very difficult to get clear information on exactly what the metrics were in this original paper. So the paper that they're referencing is was published in 2018, and it was published in the Proceedings of the National Academy of Sciences of the USA, and it's called the Biomass Distribution of Earth. Now, there are a lot of different things accounted for. It's a very extensive survey of Earth's biomass. But yes, one of the things that appears, at least, to be conspicuously absent is an attempt to accurately estimate particularly marine microorganisms. It may be that they've accounted for macrofauna, things like whales or some fish. It's not quite clear, but certainly there doesn't seem to be attempts to account for microorganisms in the earth, especially things like zooplankton and cyanobacteria. And
yes,
after we discussed this point beforehand, I went and did a lot of digging around to see if I could find accurate figures for the mass of those organisms, and I found huge variations. Some estimates were putting the total mass of marine microorganisms as high as 1 teraton on their own, which would completely change the balance of this comparison. Others were putting much more conservative estimates at several gigatons, which would not be completely rebalancing this equation, but would certainly potentially double the mass of animals accounted for in this equation.
Yes.
Now, I mean, there is something here that does make me very concerned, because as you pointed out, James, that the mass, the mass of life in the oceans is enormous. And in figure 3 in this paper, there's a sort of crude accounting of the different components of human and living biomass. And in the living column, we have animals, which is coming in at 4 gigatons. And this is showing some cartoons of a rabbit, an elephant, a bee, a fish, and a whale. Although, as we said, it's not clear that fish and whales are actually accounted for in the original survey, so it's questionable as to whether that should be there. And that comes in at 4 gigatons. And then we have trees and shrubs coming in at 900 gigatons, which doesn't make up the total mass that they put in the paper. But also terrestrial trees and shrubs in comparison to marine cyanobacteria. My understanding, and admittedly I'm not a biologist, is that there is a a larger amount of biological mass in the oceans than there is on land.
Yes, but I mean, just by virtue of volume, I mean, there's just more place for it to be.
And of course, there are wide areas of the ocean that are biological deserts, but searching, for example, for one of the searches I did was just for a density map of the Earth showing the concentration of chlorophyll across the Earth, which has been measured multiple times using satellites, which essentially just measure the absorption of specific solar wavelengths from the surface of the Earth. And you can see there that there are huge densities of cyanobacteria all across the Earth's major oceans, including very high densities of cyanobacteria all across the equator in the Pacific, accounting for vast masses.
And this, I think, illustrates the fact that these metrics are not well defined. And that's, I mean, you can define a metric, or you can try and come up with a quantity, and I think they go some way to addressing the uncertainty in the quantities to a certain degree. But the problem then, of course, is that they don't actually look at the each quantity in isolation. They try and say, well, if we look at both of these quantities as a function of time, then the intersection point is, 2020 plus or minus 6 years.
Although it has to be said that if you account for the error that they have on the biomass measurement, it's actually significantly more than plus minus 6 years. If you look at the confidence interval, the single standard deviation confidence interval that they supply in both Figure 1 and Figure 2, the earliest possible intersection date is actually about 2001, and the latest possible intersection date is about 2040.
Yes, that's right. There's nothing inherently wrong with comparing two uncertain quantities and coming up with some metric which is in and of itself uncertain, as long as you assert those uncertainties and take those uncertainties into account with your subsequent analysis, of course, which there isn't very much of in this paper. But I think we can go further and ask, what is the purpose of comparing biomass to anthropogenic mass at all?
Yeah.
Is there, other than making a broad allusion to the fact that mankind is having an impact on the Earth, which we know, I mean, there's nothing wrong with drawing attention to that once more. But it seems odd coming up with a number, 2020 plus or minus n years, because when you do something like that, you're trying to make some quantitative analysis of, you need to be able to draw conclusions from that number. And I guess the conclusion they're trying to say here is that its time is critical and that the crossover point has come now. But as we've made clear, that crossover point is actually quite variable depending on the uncertainties of the quantities involved.
Yeah.
And furthermore, they by making a direct comparison and by working out this crossover point, they are in a quantitative way, they seem to be saying that, in some sense, 1 unit of mass of anthropogenic mass is equivalent to, in some sense, 1 unit of biomass.
Yeah.
In a quantitative way. But as I think is clear to the listener, it's not really very easy to describe in any meaningful way how 1 unit of biomass is equivalent to 1 unit of anthropogenic mass.
Yeah, exactly. I think one of the critical questions that we should be asking on scrutinizing this paper is, why is anthropogenic mass bad? What is negative about it? Because if I'm going to put on my good faith hat, then I would say that this paper is here because the authors are working in this new field that they sort of say has been coined, relatively recently, which is called
Mass balance accounting.
Mass balance accounting, and they're putting together, the first comprehensive study in this field, and that's fine. But they can't have gone into this unaware of the cachet that a title like this has.
No, agreed.
And it clearly seems to imply that this buildup of anthropogenic mass is bad, and we should be concerned about it. So the key question to ask is, why is the anthropogenic mass bad?
Yes.
Now, we can point to things like plastics, and we can say the buildup of plastic in the oceans is a bad thing. The erosion of plastic into microplastics, which accumulate in the organs of animals and can toxify soil, is a bad thing. But if you look at these figures, the actual mass of the plastic here is a tiny sliver in comparison to the total anthropogenic mass. That's not to downplay the impact of plastic. It's very, very bad that we have such a huge accumulation of plastic, but it's not being accounted for properly. Its impact is not being accounted for just by measuring its mass. Whereas I would argue that building a city that's full of concrete is not that bad. Concrete, to most organisms, it's very similar to stone. Plants can grow on it. It can be broken down by natural weathering processes. It doesn't produce that many toxic byproducts.
If I may, just to interject, I think concrete might be a bad example. And again, I'm no expert on construction or concrete, but I'm fairly certain that the setting of concrete, the chemical process by which concrete sets, releases quite a significant amount of carbon dioxide, and therefore does actually have a direct impact on climate change. But your point is valid. It's in all other respects.
That's a very good point, though. That it's important to be reminded of that. Yes, the actual construction process for concrete is quite damaging. I suppose my point was more that if the concrete is built, unlike plastics, where once it's discarded, it builds up in the oceans and it forms microplastics. If you build something out of concrete and then it decays, its decay can be not harmless, but at least low impact.
Yes, that's correct.
I
just want to your point about the plastics. The impact of plastics not being properly conveyed by the metric of anthropogenic mass is problematic. But I feel also, and as you pointed out, in the diagram in Figure 1 of this paper, the other, in inverted commas, which is the plastic and everything else category, is a tiny sliver on the very top of this. I can't remember what it's called, the type of graph where you have segments like this, but and therefore not only does the metric not take into account the severity of the secondary and tertiary processes by which plastic can be sort of integrate itself into the biosphere and cause problems, but the paper itself is not fully attributing the negative impact of plastics. Not attributing. It's not fully capturing the negative impact of plastics by virtue of the fact that it's considered in this inverted commas other category because it makes up such a proportion of this metric of anthropogenic mass.
Yeah, indeed. And I mean, I would argue perhaps, I'm not a conservation scientist, I'm not a climate scientist, I'm a physicist, but studying things at the level of fundamental physics can give you a certain sort of wider perspective sometimes, not to be arrogant about it, but one of the things I find useful to think about is, why are the processes that we're engaging in, why is the way we structure our economy so damaging to the environment? It's not necessarily an inherent thing. It's not as if every activity that humans partake in is necessarily bad because we're humans and we're, somehow not natural.
Yes.
It's because we do specific things that have specific impacts. Plastic isn't bad just because it's made by humans. It's bad because it's made from the products of oil that has undergone anaerobic decay and therefore contains these toxic byproducts, and it doesn't decay through natural decay modes, and so it remains there for long periods of time. There's lots of arguments as to why plastic is bad, but it has to do with the specific composition of it. If we were to restructure human activity to de-emphasize or to move away from these damaging practices, the fact of human activity itself is not always bad.
No, that's
and
right.
that seems to be what this kind of metric implies. It's just sort of, well, this mass has been touched by human hands and is therefore bad, whereas this mass, which is natural, isn't bad. And one of the things that I find so frustrating here is this biomass, this, you know, the anthropogenic mass is broken down into these categories. The biomass is just given as this sort of one flat line, which is then the only place where they really expound the details of what it contains is in the methods section, where they talk a bit about the estimates, and in this sort of slightly cartoony breakdown. But they don't really go into the details of it, except to say that their biomass calculation contains farm animals.
Yes, and the fact that it's being included, I mean, you know, really you need to have another category, which is anthropogenic biomass.
Exactly. Why are chickens that have a demonstrable negative impact and are a monoculture and take up vast amounts of land, and cattle as well, they're all included under this biomass heading? Now, if you take this, you know, completely at face value and you just sort of say, well, these authors are doing this big meta-analysis about, you know, the makeup of the earth, then that's fine. You can say, well, chickens are biological, so they go under biomass. But under this kind of wider philosophical statement that we're at this tipping point, it seems nonsensical to do that. And it seems like the metric is very arbitrary.
Yes, I think that's really the watchword of the paper, is arbitrary.
Yeah, I mean, another thing that they've done in the biomass calculation is they've elected to use the dry biomass. Now, that's basically the mass if you were to take all the biological organisms on the planet and desiccate them and remove all the water, what you would be left with. Now, to be fair, it does seem like a lot of papers in this field focus on dry biomass, so it may simply be a matter of course for this field.
Yes.
But notably, if you use the wet biomass, so containing water, the total mass of organisms on the planet almost doubles. And the intersection point, using the extrapolation of that graph, doesn't occur until 2037, which makes for a much less exciting headline.
Yes, that's right. So I guess at this point we should identify if there are any conclusions that the authors draw from this discovery that they have made, that these two quantities which they have picked intersect at the year 2020 plus or minus 6 years, what meaningful conclusions they can draw.
Well, that is the 1.2 teraton question. I mean, one of the problems with this paper is conclusions are very, very thin on the ground. Other than the fact that these masses intersect in the year 2020, and that's frightening, there isn't a great deal of discussion, and I find that very problematic, because it sort of is just making this kind of general statement that we're at this crossover point and this is in some sense bad.
Yes.
And it offers very little in terms of wider context. And I think you and I, we both discussed a lot of more interesting questions that we would have loved to have seen asked of this data. This data set is incredible, the amount of data that's contained here, the summary of all mass, well, not all mass, but all processed mass on the planet, is this incredibly rich data set, and the question that they've asked of it is incredibly surface level and pointless. And I don't know, I mean, what do you think would be, if you had access to this data yourself, what would you try to find out with it?
The first thing that came to mind was, rather than trying to come up with some arbitrary intersection, try and study anthropogenic mass in isolation. So try and understand, for example, if you do some nonlinear regression, what the critical exponent is. So that's just, the rate at which it's increasing effectively. And that just hasn't even been considered as a question. Now, it's possible that they elected not to do that because, for whatever reason, the data didn't exist. I haven't studied the data set in detail myself. However, I feel like if you're looking for a quantity which is going to inform people as to the rate at which this quantity is increasing, and therefore how concerned we should be, a more traditional regression analysis of the data would have been perhaps not as eye-catching, but certainly more effective.
Yeah, indeed. And the efforts to sort of extrapolate the data forward are very limited and mainly just use a kind of linear extrapolation. And from that, it's very difficult to get any, as you say, any more complex projections that can tell us, for example, is the rate of anthropogenic mass generation increasing or decreasing? Are certain sectors increasing their dominance or decreasing their dominance? For example, is the rate at which new concrete is being created, is that growth exceeding the rate at which new plastics are being created? We're obviously, at the moment as a society, globally, trying to focus on tackling plastic waste. Is that having any effect? And can we see that in the data?
Yes, that would be interesting.
And one of the questions I'd really like to see from this is basically a flow diagram to break down some of the critical resources on Earth and try to show whether resources that used to be primarily consumed by biological mass have been diverted into anthropogenic mass, because that to me is one of the key questions. If we have certain organic molecules or certain minerals that are critical to life on the planet, and we can show clearly that they're being diverted into artificial construction, we can identify that as a critical point where the consumption of a certain resource is switching from being primarily biological into anthropogenic. And you can immediately extrapolate from that the impact that it would have on the diversity of life on Earth.
Yeah, that would be a really interesting thing to study.
But unfortunately, none of that has been done here, which leaves us rather frustrated. And
I feel at this point, there's really nothing else to say about the conclusions that the authors draw from the data which they have, because the metric that they've defined is largely uninteresting. So I guess that brings me to the question of, if we assume that the authors were acting in good faith, which I think they probably were, why did they decide to study what they did, and rather than perhaps something which could have yielded more enlightening results?
It's a difficult question to answer with the caveat of assuming they're acting in good faith. But one of the things that I think is clear from a paper like this is how big an impact certain types of results and certain types of discussions can have on public discourse. I mean, something like what you were discussing about performing a regression analysis, or what I was discussing about looking at the flow of resources, that is a really big job. It takes a lot of meta-analysis of the preceding works, and it requires coming up with entirely new models to map the materials flows. It would take a long time. Now, a study like this is essentially taking data that has been compiled in other publications and kind of replussing it, repackaging it to show it in a more easily understandable light, which is not a bad thing. It's a good idea to take complex data and reduce it to a form that can show things that might be hidden in a large and complex data set. But I think one of the key points here is that This is not a paper that was published in the proceedings of a conference on anthropogenic mass. This is not a paper which was published in a moderate impact journal that, bills itself as being a discussion of existing data. This is a headline paper, a front cover paper. I don't know if it actually had the front cover, but judging by the amount of traffic it's got, it could well have been a front cover paper in Nature, the highest circulation. Is the Lancet higher? I'm not sure. It's certainly one of the 3 highest circulation academic journals in the world. And ultimately, that comes down to the title, in my opinion.
I think that's right. But, I mean, I guess it's worth highlighting the fact that such papers, which are, I think it's not unreasonable to say, are promoting themselves by having titles which are, for lack of a better word, provocative. There's not really anything wrong with what they are. If what they were trying to do was inspire movement on by people on this planet to changing the way that we impact the world, and the way they decided to do that was to construct this metric and publish this paper in the highest impact journal in the world, to create a conversation about the topic which they're obviously trying to talk about. There's nothing really wrong with that inherently from a motivation perspective. However, the concern I think that you and I have, Tim, is that the work that they did is, when you dig down into it, not particularly enlightening. And therefore, when in fact there were other questions, I mean, not just the questions that we've come up with, I guarantee you there are more which escape us, but people who are more familiar with the field would be able to come up with, which would be more interesting to look at and would provide greater insight and perhaps, point towards ways in which we can be actually affecting change. And this paper, I mean, media exposure is not a zero-sum game, but, it took up, the news cycle that it did with data and research, which isn't particularly useful.
Indeed. And I think maybe this is a point where we have to give a very brief summary of how academics actually measure their careers, how they keep their jobs. Because academics, I know, you're a fully paid up member of society now, James, and you've left the bubble. But the thing is that academics, we don't create generally saleable products. We do not have an easy financial metric to determine whether our work is valuable or not. So how we do it is how we determine whether someone is actually performing well or not is by assessing their impact. And I've said that word probably like 10 times throughout this conversation without defining it, but impact in academic circles has a very strict definition. It is basically how much your work is read in your field, how many people base their work on your work, and how much your work shapes the field in which you are performing your research. And the primary way, obviously, what I've just described there is about as fuzzy as it gets. There's no easy way of defining any of those things. But so the primary way academics measure their impact is by the journals that they publish in. So if you publish 20 papers but they're all in small conference proceedings journals that are only read by a handful of people, you will struggle to find your way into top jobs, and you will struggle to get your research funded. If you're publishing an article a year or an article every few years in a journal like Nature, you can rocket yourself to the top of your field and really take control over the direction that not just your research, but also the direction other people's research
That's
will
right.
have for
And
decades
I think
to come.
what you're driving at is that, therefore, it is incentivized for you to write papers that are likely to be picked up by large journals, and more. I guess, what you didn't mention is that not only do you need to publish them in high impact journals, but they need to get cited a lot of times by other scientists. And the best way to do that is to make sure that you are dealing with a topic which is popular, effectively. And I think really this paper hits all of those notes, is that it is in a high impact journal. It is obviously got a lot of profile, and I have absolutely no doubt will be cited many times, largely due to the fact that other people are going to attempt to publish papers on similar topics, because of the fact that it is obviously such a flashpoint for focus by news organizations or whoever it may be. So it's kind of creates a feedback loop almost.
Yeah, and I'm going to get a little bit grumpy old man here. I'm going to try to restrain myself a little bit, but I think what you're identifying there is the way that I'm not going to say the economics, because the economics of academic publishing is a whole separate debate, but perhaps the social aspect, the environment of academic publishing has changed so much in the last 20 years. Part of the motivation of that, I think, is the way in which the public engage with science has changed, and in many ways for the better. So reading articles about real cutting-edge academic research is so much more popular now than it was even 20 years ago. There are whole channels on YouTube, there are entire websites, there are
Podcasts.
Vast amounts of podcasts, indeed, that are entirely devoted to a love of science. And that's wonderful. It's so fantastic that science is no longer something that people think is only done by people in lab coats who wear Coke bottle glasses. It's great that science has become this mainstream touchstone. But one of the side effects of that is that academic publishing has taken on a lot of the pitfalls of social media.
Yes, I think that's right.
Yeah, and if you... Obviously, this doesn't apply to everybody, but there is definitely a trend where if you can tap in to something that is going to set a trend, something that's going to go viral, which this paper arguably has, then you can almost bypass the traditional checks and balances that exist on scientific endeavour and publish work that will have a massive impact, even if it's not actually up to the standards to which such work would usually be held.
Yes, that's right. And I think it creates, again, a feedback loop for the individual, not only for the particular topic, in that the higher impact you are as a scientist, the more likely you are to be able to be allocated funding, which in turn allows you to publish more papers, and the more papers you have, well, this isn't always true, but assuming that you understand the system, the more papers you have, the more likely you are to have a higher impact as a scientist, and further get more funding, which is not really the way you want things to go if you want the system to be structured in a way that incentivizes good science.
You desperately need, in science, resources are limited. Resources in science are always limited because they're provided by the public, and so that you can't just find a technology. I'm saying it like that's easy, but even if you were to find a technology that was transformative and you were to publish on it, you can't make a business out of that because your research is publicly funded and ultimately it's publicly owned, or at least that's what I believe. Not all scientists would agree.
It should be.
Yeah. And so resources are always going to be tight. And there's a desperate need to prioritize who gets those resources. You need to make sure that people are getting resources who are doing good research. But there's a tendency to assume that the metrics, the very shallow, very flawed metrics that are used to measure impact, are all one needs to best assign public resources, and that is simply not true. You have people who are incredibly adept at getting their papers published in the top journals because they know the game. And that's not to say that they're fraudsters. The science is accurate. The science is generally correct. A paper doesn't get published in Nature if it's total bullshit. At least, well, I mean, they have at times, but it's not common for that to happen.
No.
But sometimes the difference between a particular research topic being published in Nature or being published in, the journal of the conference of, I don't know, whatever, can simply be the name of the first author. And it's got nothing to do with the content of the paper.
Yes, that's right. I think we should draw our conversation to a close.
Yeah, probably, before I get myself in too much trouble.
That's okay. All in all, I thought that this paper, the analysis that it actually performed, it performed reasonably well. They did indeed calculate the errors in the quantities that they were studying, sort of. Although, as we've discussed, the definitions of the quantities involved were lacking, shall we say. And the conclusions drawn from the paper were non-existent, really.
Because there are no conclusions that you can draw from this, because the metric doesn't mean anything.
Exactly.
I mean, one of the quick sort of back-of-the-envelope calculations I did when I first read this was to look at what the authors of this paper say the total mass of all the matter on the surface of the Earth is, which is 2.4 teratons. And I did a quick calculation to see what the actual density of matter was on the surface of the Earth. And I excluded the ocean because, as far as I could tell, they also excluded marine mammals. So on the basis of this, just from the surface area of the Earth, both artificial and biological matter would have a density of about 14 kilograms per meter square, which is just enough to have a 1 centimeter deep layer of soil and concrete and bricks over the landmass of the Earth, which is clearly not right. That estimation shows that there's something deeply wrong here. And what's deeply wrong with it are all the things that we've mentioned. It's not including soil. It's not including dead matter. It's only including living biomass, not dead biomass. It's not including water. It's not including other types of anthropogenic activity which can manipulate the mass on the Earth without explicitly generating something artificial. It's just full of holes, and it doesn't represent the biosphere of Earth as it actually exists.
Yep. That's an accurate summary.
So, yeah, I guess it's completely understandable if you're reading this headline that you would be freaked out, and you should be freaked out about climate change. It is fucking scary. I'm not supposed to say fucking. It is very scary. But this paper is not implying that we're on the brink of a Blade Runner future.
No, I think that's definitely not the conclusion that we can draw from this study.
And to frame climate change in those terms, it actually undermines action on the problem rather than enhancing it.
Yes.
Cool. That's a wrap. A soy
delicious
wrap, seaweed wrap.
Tasty wrap.
If I wrap myself in seaweed, is that artificial mass or biomass?
It makes you onigiri, that's what it makes you.